Hi, algebra students. So we finished up a unit and we are getting ready to start our new unit today. And so if you want to make a little note at the top of your next page in your notes, this is Unit 6. And the title of this unit is Systems of Equations. Systems of equations. And if it's okay with you, from here on out, I'm gonna abbreviate system of equations with SOE. So anytime I write SOE, just know that that means system of equations. So we're going to talk about what a system of equation is today, and also how to solve it. So there are actually several different methods that we're going to use to solve systems of equations, depending on what they look like and how difficult they are. So we're going to start pretty easy today. And so the title of today's notes, starting Unit 6, are going to be solving systems of equations. And again, I'm just going to write SOE. Solving systems of equations using substitution. So go ahead and write that title down, and then we'll talk about what a system of equation is, and then we'll talk about this method of solving it called substitution. So system of equation is just a fancy way of saying two equations. So let's write this down. So system of equations, SOE, the definition is two equations or more. We're going to stick with two, but you could have more. Two equations which are true with the same x and oh, it's supposed to be the word and, not any, and y. I was trying to write any and y at the same time. With the same x and y values. So two equations which are true with the same x and y values. So let's just look at a real quick example. So if I said, okay, I know that x plus y equals 5. And then I know that x minus y is equal to 1. This is what we call a system of equations. It's two equations, and they are going to be true at the same time with the same x and y values. So let's just take a second and think through this sort of intuitively without doing any solving. Can you think of two numbers that when you add them together, they come out to be 5? Well, we could use 4 and 1, or 3 and 2, or 2 and 3, or 1 and 4, or 5 and 0, right? All of those things come out to be 5. So with only one of these, if we didn't know this, x and y could be anything from 0 to 5. However, this next equation sort of limits us to what they can be, because this second equation is telling us that whatever these two numbers are, you also have to be able to subtract them, the x minus the y, and you need to get 1. So what combination of numbers works? Well, it has to be 3 plus 2 is equal to 5, and 3 minus 2 equals 1, right? So therefore, x equals 3, and y equals 2. Now, that's pretty straightforward, and that's probably the easiest of these that you could come up with, because again, that was sort of intuitive. We only had a limited amount of numbers. But imagine if we had coefficients here, if we had these in different orders, these can get pretty difficult. So one of the methods that we're going to use in order to solve a system of equation is what we would call using substitution. So now that we know what a system of equation is, let's draw off our, let's make a line across here. And actually we're going to do 6 different examples. So if you want to, just split the rest of your paper in half, and we're going to fit 3 examples on each side. So let's go ahead and jump into example number 1, and let's look at this system of equation. So you're going to see a few systems that look like this. So it's going to tell us, again, it's going to give us 2 equations. So the first equation is x equals 8. It's pretty straightforward. And then the next equation is y equals negative 2x plus 4. Now you might be thinking, okay, well that first equation, again, remember an equation is anything with an equal sign. So the first equation looks pretty simple, right? It's just telling us that x is equal to 8. Well, think about what it means to substitute something. We did this back when they told us what a variable was and we plugged it in to an equation. That is exactly what we're going to do here. So substitution means that I know what one of the variables is equal to, and I'm going to take this information, so this x equals 8 information, and I'm going to substitute it in for what I know is true in my second equation. And so what I'm going to do is I'm going to take my x is equal to 8. I'm just going to drop the 8. If x is 8, then in the second equation, I should be able to take that 8, plop it right down right there, and then find out some more information here. So I'm just going to go down to the next line. I'm going to write, well, if this is true, then y is equal to -2 times 8 plus 4. I just plugged that 8. I substituted that 8 right in there. And then here's some math for me to actually work out, right? So y is equal to -2 times 8 is -16 plus 4. And so that must mean that y is equal to -12. And so the whole goal of you solving a system of equation is this, to figure out what x and y is. And now, look at what we just did. Do we know what x is? Well, yeah, we knew that in the beginning. It was x is equal to 8. Do we now know what y is? Well, yeah, y is equal to -12. And so there is your answer. Now, most of these are going to have x and y in them. So x and y can also be written as an ordered pair. So you also might write your answer. It may be written as x is equal to 8, y is equal to -12, but just know we could also write this as an ordered pair where x is equal to 8, that would come first, and then the y value is 12. So you could also write it as an ordered pair since you have an x and a y value there. And so those are the two values that make both of these original equations true, because x is equal to 8, and if we plug in 8 to this, we get out a value of -12 for y. All right, let's look at another example. Example number 2. Our system is going to look something like this. Y is equal to 3x, and then 5x minus y is equal to -18. So now we have two equations that are a little more complicated, and we aren't just given one value like y is equal to 3. We're given that y is equal to 3x, and then we have this piece of the second equation as well. So again, we're going to look at what we have, and the first thing you're going to look for is, do I know what either, just like over here, we knew what x was equal to, and we substituted it in. We're going to look over here. Do we know what x is equal to? Well, no, we don't have anything here that says x is equal to. But do we know what y is equal to? Well, yeah, y is equal to this 3x here. And so if I know what y is equal to, even though it's not just a number, I'm going to take what y is equal to, and I'm going to substitute it in directly where y is. Now, in this case, y is 3x, right? Y is equal to 3x, which means I'm going to take 3x, and I'm going to drop it in directly where I see that y. If y is the same thing as 3x, then I should be able to take 3x and substitute it in for y. And so here's what the second line of this equation is going to look like. 5x minus, I'm going to drop in what I know is true about y. Y is the same thing as 3x, so I substitute that in, is equal to -18. Now I look around. Once I've made that substitution step, I look around and I say, okay, is there any math for me to do here? Well, yeah, there is. 5x minus 3x. Do I know what that could simplify to? Well, yeah, 5x's, take away 3x's, is 2x's. And now I look like I'm making some progress, because now can I solve for x? Well, yeah, if I divide by 2 here, then I know and I find out that x is equal to -9. That's 18 divided by 2. Okay, so now I know what my x value is, which means in my ordered pair I could put -9 first. X is equal to -9. But how am I going to find out what y is equal to? Well, think back to where we started up here at the beginning. If I now know that x is equal to -9, then I knew in the beginning that y was equal to 3x. Well, if I know what x is now I can substitute. So it's almost like there's two substitutions here, right? We substituted in the 3x first, but now that I know that x is equal to -9, what I'm going to do is I'm going to take my x value, -9, and I'm going to substitute it into where I started. So we're going to say y is equal to 3 times, what is x? X is -9. And so I plug in -9 there, and so what should y be equal to? -27. -27. And here's how you'll know you're right. You can take Desmos, you can take your calculator, you can take your phone calculator. I've only got a little tiny handheld calculator right now. But if I do, we want to make sure that this is true, right? So if I do 3 times x, which is -9, I know that that comes out to be my y value of 27. Does it work in this equation as well? So what is 5 times x? Well, 5 times x is 5 times -9. 5 times 9. I don't even have a negative on this calculator. That's not going to work. All right, well, that would be -45, right? And then -45 minus my y value, which is -27. I'm not going to be able to do it on this calculator. Let's see if I can find a calculator that actually has a negative button on it. All right, this is old school calculator here. It doesn't even look like it lights up directly. All right, let's see. Let's see if we can type this in. So I'm just checking my work here. So 5 times the x value, which was -9, so 9 negative, and that equals -45. Ignore that, that's a decimal right there. This is a weird, wonky calculator. I don't have my Desmos up right now. So -45, and then we're going to subtract the y value, which was -27. So subtract 27 negative. That gives me, I don't think it did something right there. -45 minus, oh, it's doing weird stuff, y'all. I might as well go find a Desmos. Give me a second and I'll come back. This is what happens when I do notes the first time after Christmas. All right. I told y'all these notes videos were going to get way less professional, and they are. All right, let me show you how to check this one on Desmos. Here we go. This will make it much easier. All right, so we had 5, our second equation was 5 times the x value, which we found to be -9. It's way easier typing it on Desmos. 5 times -9 minus, and then we had -27. And the answer does come out to be -18. So it takes 2 seconds if you have Desmos up to just plug these numbers back in and make sure that these values, these x and y values, work for both of your original equations. All right. Now that we're situated, let's look at a different example that's maybe in a little different format. All right, so example number 3. This is going to be, and I'm going to write these next to each other just to give ourselves a little more room here. So 3y plus x equals 7. And then the second equation is 4x minus 2y is equal to 0. Most of the time for substitution, you'll want to write your equations. If you're working this out on a piece of paper, it's easier if you'll write them out next to each other like this rather than stacked on top of each other, because the more complicated the equations get, the harder it is to do work sort of stacked up on top of each other like this. So I would suggest writing them out next to each other. All right, so let's look at what we've got here. We've got 2 equations. We want to find out what x and y are at the same time that both would satisfy these equations. And so we look, and the first question we always want to ask ourselves is, do I know what x is equal to? Or do I know what y is equal to? Because up here we knew what x was equal to. Here we knew what y was equal to. So we notice the first thing here, I do not have an x equal to or a y equal to. That's the first thing I notice. So I need to manipulate one of these equations in order to get either x by itself or y by itself. One of the variables needs to be by itself. So most of the time there's going to be one that's a little easier than the other. So if you'll notice, see how x is already by itself here? But over here, both x and y have coefficients, and here the y has coefficient. So the very easiest thing for us to do is going to be to get this x by itself because it's already by itself. So if you'll look for like the single variable, that will probably make your life a lot easier. So I'm going to get rid of the 3y on this side, move it to the other side. That's gone. So now I get x by itself. So x is equal to 7 minus 3y is what we get. And so now I do know what x is equal to, right? It's x is equal to 7 minus 3y. So I'm going to use my first substitution step. If this is what x is equal to, I'm going to take this and I'm going to drop it in where I see the x over here. Now this is going to get a little trickier because of this 4 in front here. So here's how I'm going to write this. 4 times, I'm substituting in the x value. X is equal to, I'm going to put parentheses around it because of this 4 in front, 7 minus 3y. So all I did again was I just like picked this up and dropped it in exactly where I saw the x. Then I still have minus 2y is equal to 0. But again, just take a second and make sure that you understand that since I knew that x was equal to 7 minus 3y, I picked it up and I put it in for the x. Now I put it in parentheses because of this 4. It's going to be important that it's in parentheses because it's 4 times x. It's 4 times this whole thing. All right. So now I have a little bit of math to do. So anytime I see a number on the outside of parentheses, I definitely want to distribute. So 4 times 7 gives me 28, and then 4 times negative 3 gives me negative 12y, and then minus 2y is still on the outside is equal to 0. So I've distributed. There are some like terms that I combine. I'm using DCBA, right, to go through my steps here, just like we always solve an equation. I'm able to combine my like terms. So we've still got the 28 out here, but now I'm going to do negative 12y minus 2y, which gives me negative 14y is equal to 0. Now I'm getting closer. Notice, again, once I made this substitution, I only have a y left. So I'm trying to get y by itself here. And so the next thing I'm going to do is I'm going to move the 28 over. So it's positive 28. So I'm going to subtract negative 28 from each side, or subtract 28. So I'm left with negative 14y is equal to negative 28. 0 minus 28 is negative 28. And then the last step is to divide by negative 14. Divide by negative 14. And we get y is equal to 28 divided by negative 14 is positive 2. All right, so that's nice. And when you do come out with a y value, for the questions that we're going to answer, they are going to be whole numbers or integers, negative or positive whole numbers. They are not going to be decimals. Now, is it ever okay to get a decimal answer? Well, sure, there are going to be some that come out to be decimals, but in the practice that I have selected for you all for this unit, your answer should come out to be a negative or positive whole number. All right, so now we know what y is, but do we know what x is equal to? Well, we do, but it's 7 minus 3y. Now that we know what y is equal to, we're able to make a substitution this way, and we're able to plug in that 2 where we see the y. So I'm going to go back to we're always going to make a substitution, solve, make another substitution, solve. So this is going to give me my x value. So x is equal to 7 minus 3 times the y value is 2. So I plug in my 2. And so I get x is equal to 7 minus 6. 3 times 2 is 6 using order of operations. And then x is equal to 7 minus 6, which is 1. And so my x value is 1 and my y value is 2. And if I want to use Desmos in order to check myself again, then I'm just going to look at what my equations were. So I'm going to type in 3. The original equation was 3 times y, which I'm saying is 2, plus your x value, which was 1. And that does give me 7, so that's good. And then I check the second one, 4 times the x value, which was 1. So 4 times 1 minus 2 times, and my y value was 2. And that should equal 0, which is exactly what that second equation said. So it checks out. I know that my x and my y value make both of my equations true. And so I have the right answer. And again, you could write this either as x is equal to 1, y is equal to 2, or 1, 2 in order pair, remembering that x always goes first. All right. Let's look at our fourth example. Example number 4. We have to go into the back of this to finish up examples 5 and 6. All right, so example number 4 is going to look like this. So we've got y is equal to 2x plus 1, and y is equal to 4x minus 1. Now, notice over here, our question was, well, neither of these are solved for x or y, so I had to solve one for an initial variable first. Well, here we've got 2 that are actually already solved for y. And this actually makes it a little easier when they're already solved for y, because if y is equal to 2x minus 1, then all you have to do here is you're just going to take one of the entire sides. It doesn't matter which one. and you're going to drop it in where you see the y on this side. So I'm going to make this initial substitution, and I'm just going to plug in the 2x plus 1 is equal to 4x minus 1. I'm really just going to set them equal to each other, right? Because if y is equal to this and y is equal to this, then actually these two things are equal to each other. Now, you are going to have to do some bringing some variables to one side. So we'll subtract 2x from each side, and we get 1 is equal to 4x minus 2x is 2x minus 1. We're going to add the 1 to each side. Cancel it out over here. We get 2 is equal to 2x, divide by 2, and we get x is equal to 1. And then again, we're going to make that last substitution back to figure out what y is. So we're going to go back to the beginning, and we're going to do y is equal to 2 times 1. I'm going to drop in the 1 for the x plus 1, and so y is equal to 2 plus 1, y is equal to 3. Now, a lot of people would be tempted here to write that the answer is 3, 1, but again, make sure you're paying close attention to what order. That is not right. The answer here would be 1, 3, because again, x comes before y. All right, and so those are your 4 examples of general how to solve an equation, how to solve a system of equations with substitution. If you'll flip over to the back of that page, my ink is going to come through, so I'm going to go actually over to it. But if you'll just put these on the back of this page, let's look at some special cases. So I'm just going to make a note that these are special cases of systems of equations. And so just real quick, we're going to look at 2 examples. So this is example number 5. And I'm just going to stack them on top of each other. So x is equal to 3y, and then x plus y is equal to 7. And so we look, again, first, our always question we ask ourselves is one of these already solved for x or y? And it is. This one is already solved for x, so I'm going to notice that if that's what x is, then I'm going to drop that in and substitute it in where x is over here. So there's no coefficient out here, so I don't have to put it in parentheses. So I'm going to drop in the 3 minus y where the x is, but then it's going to be plus y is equal to 7. Now here's where the fun starts, because when you combine these like terms, what is negative when there's really a 1 here, right, in front of both of these? What is negative y plus 1 plus y, or negative 1y plus 1y? Those are going to cancel, right? Negative 1 plus 1 is 0, and so we get the answer 3 is equal to 7. Now that has happened to us before when we were dealing with one equation, and when does this happen? This is when there are no solutions. So if you get this right here, this false statement, something that's not true, your answer is just going to be no solutions. There is no solution to this system of equation. There are no values of x and y that will make both of these true at the same time. In other words, there are no 2 numbers that you can add together to get 7 that you can then subtract the y value, 3 minus the y value, and get the x value. There's nothing that will work there. If you don't believe me, you can think about that a second, try some numbers and see if it works. The only numbers that you could actually work are 0 and 7, 6 and 1, 5 and 2, 3 and 4, or they're vice versa, and none of that will satisfy this. So if we have a no solution, I bet you can guess what the 6th example is going to be. So example number 6 is going to look like this. 2x plus y is equal to 4, and then the other equation is going to be 4x plus 2y is equal to 8. And so again, we're just starting with a normal system of equations, and we ask ourselves, is one of these solved for x or y first? And no, they're not. We don't know what y is equal to, or we don't know what x is equal to. Right now they're in combination, but can we solve for either x or y very easily? And so remember, look for the isolated variable already. All of these have coefficients except for this y. This y is already by itself, so I'm going to solve for that y that's already by itself. Now next week we'll talk about what happened if there was a coefficient in front of that. There's a different method that we'll use besides substitution. But I'm going to go ahead, because I do have a variable by itself, I'm going to go ahead and isolate that one variable. So subtract the 2x's. So we get y is equal to 4 minus 2x. Now that I know what y is, I'm able to go over here and make my substitution. So there's my y value. I'm going to drop it in right here, making sure to put it in parentheses because there's a 2 out in front here. So 4x plus 2 times what I know to be my y value is 4 minus 2x is equal to 8. And then I have some distributing to do here and some combining of like terms. So 4x plus 2 times 4 would be 8. 2 times negative 2 would be minus 4x. So we just distributed here. And then that's equal to 8. And now we're going to combine like terms. 4x minus 4x. Uh-oh, same thing happened, right? As up here, they cancel. 4x minus 4x is 0. But I get 8 equals 8. And now, is that false? Well, no, that's always true. It's an always true statement. And so what do I write as my answer? This is infinite. Infinite solutions, which actually means you could pick any two numbers that work for one of these, and it will work for the other one. So let's just, if we just pick 2 and 1, well, we have to pick something that will actually work. So 2 times 1 would be 2. Yeah, 1 and 2 would work. So if x were 1 and y were 2, that would be 2 plus 2 is 4. And so if x were 1 here, this would be 4. And 2, 4 plus 4 is 8. And so it works. We could pick any other two numbers that would work, and it will work for both of the equations. So infinite solutions if you get to a point where your variables cross out and you end up with the same numbers. So in summary, you want to make sure that you know what one variable is equal to. If you don't know what one variable is equal to, you're going to need to solve for that variable, make a substitution, solve for one of the variables, and then make a substitution back into where you began. Make sure you email me if you have questions, and good luck practicing solving systems of equations using substitution.